Imagine a future where humanity's biggest journeys don't start with astronauts strapped into seats, but with intelligent machines heading out on their own, quietly taking the first steps ahead of us. Out beyond Earth's protective cradle, robots aren't waiting for step-by-step instructions anymore. They're making decisions, solving problems, adapting to chaos, and quietly building the foundations of a future that's going to change life on Earth in ways most people don't see coming yet. This isn't science fiction drifting toward reality someday. It's already happening, and its ripple effects are beginning to touch everyday life right now, often without anyone realizing where those improvements first came from. Space used to be a place humans visited briefly, at huge cost, and with enormous risk. Every mission depended on fragile bodies, oxygen, food, radiation shielding, and constant communication across mind-bending distances. Even a small mistake could end everything. That model just doesn't scale. The distances are too vast, the environments are too hostile, the ambitions are too big. What's stepping in to fill that gap is something radical, autonomous robots that can operate on their own for months or years, think locally, fix problems as they arise, and work together without waiting for Earth to weigh in. These autonomous robots aren't replacing humans. They're extending humanity's reach into places we could never survive, while quietly improving the technology that already shapes daily life back home. Not that long ago, space robots were basically remote control machines. Engineers on Earth told them where to go, when to move, and what to do next. That works fine when signals travel fast and situations stay predictable. It completely falls apart when communication takes minutes or longer and conditions change unexpectedly. On Mars, a message from Earth can take up to 20 minutes to arrive. In deep space, it's even worse. By the time instructions arrive, the moment has often passed. Autonomous robots solve this by making decisions on the spot. They read the environment, judge risk, adjust plans, and keep working even when Earth goes quiet. That single shift changes everything about what's possible. Today's autonomous space robots use artificial intelligence that's trained not just to recognize objects, but to understand context. They can tell the difference between a shadow and a real hazard, between harmless dust and serious damage. They learn from mistakes and adapt over time instead of repeating the same failures. According to NASA's Jet Propulsion Laboratory, modern planetary rovers already handle navigation and hazard avoidance on board, tasks that once needed constant human input. That same kind of decision-making already shows up in driver assist systems, warehouse robots navigating crowded floors, and drones helping emergency crews see situations more clearly. Space pushes these systems to extremes, forcing breakthroughs that spill back into everyday tools. Autonomy really starts to shine when robots work together. Instead of one heroic machine trying to do everything alone, researchers are building robotic swarms, groups of smaller robots that communicate, split up tasks, and adapt as a unit. If one fails, the others adjust. If terrain changes, the whole group reroutes. The European Space Agency and several research labs are testing swarm robotics for asteroid exploration, where gravity is unpredictable and surfaces are unstable. These systems borrow ideas from nature, like how ants build complex structures, or bees coordinate hives. Except the intelligence is artificial and massively scalable. At first glance, this might feel far removed from everyday life. Most people aren't planning to explore an asteroid anytime soon, but swarm robotics directly influences how supply chains run, how disaster zones get mapped, and how infrastructure gets repaired faster and safer. The same coordination logic designed for space swarms is already being adapted to manage traffic flow, balance energy grids, and coordinate fleets of delivery vehicles. Space robotics becomes a pressure cooker for technologies that quietly lower costs, reduce waste, and improve reliability here on Earth. Another major shift happening right now is autonomous construction in space. This isn't about factories or manufacturing lines. It's about robots assembling structures on their own, adjusting to microgravity, extreme temperatures, and radiation without constant supervision. NASA-funded research has already demonstrated robotic systems assembling truss structures in orbit, proving that machines can build with precision even in weightless conditions. Private companies are developing autonomous docking and assembly technologies that allow satellites to organize themselves after launch, reducing the need for risky human intervention. That matters because autonomous assembly slashes the cost of space infrastructure. When robots can build and maintain systems without humans riding along, satellites get cheaper and missions become more flexible. Cheaper satellites mean better global communication, more accurate weather forecasts, faster internet in remote areas, and more reliable navigation services guiding everything from smartphones to emergency responders. The invisible backbone of modern life gets stronger because robots learned how to build in orbit. Self-repair is another quiet revolution unfolding above our heads. Space is brutal. Tiny micrometeoroids can cause damage without warning. Radiation slowly wears materials down over time. Autonomous robots are being designed to spot problems, figure out what's wrong, and fix it without waiting for instructions. Some systems can even predict failures before they happen and adjust operations to stretch mission lifespans. Research published in journals like Nature Machine Intelligence shows how space-driven constraints are accelerating advances in self-healing systems. Those same ideas are already improving life on Earth. Predictive maintenance systems inspired by space robotics now monitor bridges, power plants, factories, and transportation networks. Instead of reacting after something breaks, these systems spot trouble early and fix it before it turns into a crisis. That saves money, prevents accidents, and reduces downtime people feel in their daily lives. Space demands reliability. Everyone benefits from it. Autonomous robots also open the door to places humans simply can't go. Beneath the icy crusts of moons like Europa and Enceladus may be oceans with the ingredients for life. Sending humans there isn't possible right now. Sending autonomous robots is. Space agencies are developing probes that can drill through ice, navigate underwater, and make scientific decisions on their own. These machines are built to adapt to the unknown, analyze samples, and decide what matters most without waiting for Earth. The payoff isn't just scientific curiosity. Technologies developed for these missions feed directly into medical robotics, remote surgery, and autonomous diagnostics. Systems that have to operate independently under extreme conditions translate into healthcare tools that work in rural areas, disaster zones, and places without constant expert oversight. That means faster diagnoses, better monitoring, and care reaching people who were previously hard to serve. Space exploration becomes a catalyst for broader access and better care. There's also a cultural shift happening alongside the tech. Autonomous robots change how exploration works and how it feels. Instead of heroic individuals risking their lives, exploration becomes a partnership. Humans define goals and values. Robots handle danger, distance, and endurance. That partnership lets exploration scale, meaning more missions, more discoveries, and more data feeding science, education, and innovation. Education benefits too, often in ways people don't notice right away. Data collected by autonomous robots powers simulations, virtual reality experiences, and interactive learning tools. Students can explore real planetary landscapes built from robotic scans. Concepts that once lived only in textbooks suddenly feel tangible and exciting. Educators working with space outreach programs consistently report higher engagement when students can interact with real mission data instead of abstract diagrams. It's worth noticing how often these invisible systems already shape daily life. From GPS accuracy to climate models, from emergency response coordination to global communications, autonomous systems tested in space quietly keep modern society running. If this kind of future-focused storytelling sparks curiosity about where all of this is heading, now's a great time to subscribe, like, and turn on notifications so nothing transformative slips by while it's unfolding. Autonomous space robots also push us to rethink what intelligence really means. These machines don't think like humans. They rely on patterns, probabilities, and adaptive learning. That difference makes them resilient in ways humans aren't. They don't panic. They don't get tired. They don't need reassurance. When designed responsibly, they amplify human intention rather than replace human judgment. That matters as artificial intelligence shows up in more everyday tools. Space robotics forces developers to take safety seriously. A bug in orbit isn't annoying. It's mission-ending. Because of that, many of the safety frameworks being developed for autonomous space systems influence how AI gets tested and deployed on Earth. Better safeguards, clearer accountability, and more rigorous testing end up benefiting everyone who uses these technologies. The economic effects follow quickly. Autonomous robots lower launch risks and operating costs. Lower costs attract more players. More competition accelerates innovation. That cycle fuels industries from telecommunications to environmental monitoring. Entire business models exist today because autonomous systems made continuous space operations possible. The phone in a pocket depends on satellite networks maintained through robotic processes refined over decades. There's also a quieter psychological benefit. Space exploration has always stretched humanity's sense of what's possible. Knowing intelligent machines are out there building, exploring, and learning on our behalf reinforces a shared sense of progress. It reminds people that curiosity still drives civilization forward, even when optimism feels hard to come by. Looking 5 to 10 years ahead, autonomous robots are expected to take on roles that sound almost unbelievable today. Cooperative systems will map entire worlds in fine detail. Maintenance robots will keep space infrastructure running far longer than we ever imagined. Intelligent probes will decide which mysteries to investigate first based on evolving data rather than fixed plans. According to roadmaps from NASA, ESA, and private aerospace companies, many of these capabilities are already well into testing. This story isn't about robots replacing humans. It's about robots expanding what exploration even means. They handle the impossible so humans can focus on creativity, meaning, and direction. Every autonomous robot operating in space today carries technologies that improve life on Earth tomorrow. Whether that's safer infrastructure, better communication, cleaner energy systems, or more resilient services people rely on every day. As this cosmic quest continues, the real question isn't whether autonomous robots will shape the future of space. They already are. The question is how humanity guides that partnership so exploration stays aligned with shared values and real benefits. Staying curious and informed is part of that journey. Subscribe, like, and turn on notifications to keep exploring what's coming next. This is Tech Mythos.